This is not the end. It is not even the beginning of the end. But it is perhaps the end of the beginning.
Well, thank you to Mr. Churchill, and welcome to episode 57, The Beginning, chapter 18 of The Beginning of Infinity, titled The Beginning. So I guess to be fair, it wouldn't be until next episode, or the episode after that, possibly, when we get to the end of the beginning of the end of The Beginning of Infinity, or the end of the beginning, which is the chapter called The Beginning, which comes at the end of The Beginning of Infinity. Confused? But it is only the end of the beginning of infinity, so far as I'm concerned, because there are so many more interesting things going on with the beginning of infinity right now. And if you head over to Naval Ravikant's channel on YouTube, Naval, you can find the beginnings of a new podcast series that it's been out for a few weeks now, and we're planning on taking that on for another many episodes. I'm not sure exactly how many, but this conversation that Naval and I had is being put into podcast format, and we're going to have a number of these other conversations as well, further unpacking the beginning of infinity, and perhaps trying to explain it in terminology that is even more accessible than what I've been able to do here. So go there and begin the beginning of infinity explorations all over again if you like. And further, also on Naval's channel there, you can find some conversations that I've had on this new thing called Clubhouse. There are links there to hour-long conversations or more with myself and Naval and some other people exploring the ideas that I've been talking about here. So this is all just getting started. And there are some other projects in the pipeline that Naval and I have that we're very excited about in bringing to fruition more beginning of infinity type themes. Naval has a real beginning of infinity mindset. He's one of these rare people in business who has a contrarian mindset to a large extent. Contrarian about both the typical academic culture and the typical business culture as well. And so this comes together in his love for the beginning of infinity because these ideas are about the infinite future, which is something that Naval and David Deutsch have converged upon. And it seems to be a wonderful meeting of minds that's just commencing now. So I'm looking forward to see what's going to come of the encounter between the ideas of Naval and the ideas of David Deutsch. What kind of new people might be inspired to really take seriously what both of these impressive people are saying. And it's just so appropriate today that I am making this episode because today, Sam Harris, the neuroscientist podcaster, released another one of his Making Sense podcasts, and that is titled Food, Climate and Pandemic Risk. And there is some interesting solutions in there about the ethics of eating meat, which I have my own views on, but which I know many people are very concerned about the possibility that animals might be suffering in the production of meat through factory farming and so on. Now, there are interesting solutions that Sam is interested in promoting about how to artificially create meat in the laboratory. And I think this is a great idea for a number of reasons, not least of which is, well, it's an innovative idea, and more power to people who come up with innovative ideas where there is a place in the market where people might be able to make a lot of money in order to then go on and fund other interesting, innovative ideas. But more than that, any of these kind of ways in which we can figure out how to more efficiently, I suppose, create food and feed even more people more cheaply, then that's great. Solving some of these problems of poverty in certain places where some people don't get enough of whatever nutrient in their diet, especially protein in their diet. And so if we can do this via some mass production method where it's cheaper, ultimately, in the long run speaking, than having to raise cows and sheep and that old technology of animals, and instead have just a factory pumping out steaks and pumping out chicken fillets and pumping out your lamb chops, then isn't that a wonderful idea? That's great. That's fantastic. But I bring it up because I listened to the entirety of the podcast, and although there were interesting and optimistic ways in which technology might be used in order to solve this problem, it was interesting that the speakers seemed at times to regret the fact that it came down to a technological solution, that the technological solution was only necessary because they couldn't find a political way in order to persuade everyone that what they were doing was wrong in this regard, namely that we are all terribly immoral, we who eat meat, or that we aren't concerned or taking seriously enough the existential threat of climate change, or that we simply didn't have our morals calibrated in precisely the correct way that these people thought that we should. And my last podcast, the episode before this, was just a kind of light-hearted, to some extent, exploration of existential risk. And the reason why it was light-hearted was because sometimes some of us do get frustrated with the identification of particular problems as being the way in which civilization is going to go off the rails. But the thing is that if you know there's a problem, even if you have a hint of there being a problem, then human beings will begin to course correct. They'll begin to correct their errors to the extent that they think it really is an existential threat. And during the conversation that Sam had with his guests, they were really upset about the fact that the pandemic, the COVID-19 virus pandemic that happened through 2019, 2020 and throughout 2021 wasn't responded to sufficiently quickly, and they thought this was a cause for a certain amount of despair, and that wasn't it a shame that people didn't respond faster. Now, on the one hand, I can kind of agree. It's always better if we can respond to any given problem faster than what we did, so the suffering is less. But I think the correct lens through which to look at this pandemic is that it was a pandemic that we solved faster than any other pandemic hitherto that has ever existed or affected people before. That globally, we managed to globally coordinate this response, and very, very quickly. I thought that the example of the way in which the world responded to COVID-19, broadly speaking, was a cause for optimism, a cause for hope, a cause for thinking that should we encounter this kind of thing again, we'll be able to respond even more quickly. That's the lesson of this, that the accelerating rate at which human beings are able to collaborate and come up with solutions, like vaccines, is a cause for celebration, not despair. But this is just the usual mode in which intellectuals, public academics, tend to respond to any kind of problem, as if it's a source of despair that we didn't find the solution quickly enough. But it's as if they don't know or are unaware of or simply forget that problems are inevitable. Problems will continue to happen all the time. And any one particular problem that's been identified, there is a flip side to being concerned about the fact that it might cause our demise. The flip side is, hey, we actually identified this thing in time, because we should, all of us, be far more concerned about the thing we do not yet know about the problem that is we are yet to encounter. And so the problems that we do know about, I think they are, by virtue of the fact that we know about them, are, for all the more reason, less likely to wipe us out at all. And every day that goes by that we're aware of this particular problem, it becomes less likely that that particular problem is going to, in truth, be an existential threat to us. That insofar as climate change could cause some sort of economic catastrophe, let alone environmental catastrophe, the more that becomes clear, if it becomes more clear, perhaps it will be turned over. We don't know yet. We don't know exactly what the future will hold. But insofar as it continues to persist, to be a problem globally and to cause environmental issues that scientists seem to be able to agree, and other thinkers seem to be able to agree, is actually the cause of certain problems that are happening right now, today, for example, certain weather events, certain sea level rises, certain declines in agricultural production. I don't think there has been any declines in agricultural production, by the way. It just keeps on increasing. That every day that goes by, it is less likely that we will, in the face of this, just ignore it. That the people of the world will just continue to so-called ignore it or so-called downplay it. I don't think they are. If anything, putting my cards on the table, at certain times I think there might be a tendency to overreaction, a tendency to hysteria. And I think that can sometimes be more of a problem than the problem itself, the hyperbole, because what the hyperbole does, what hysteria tends to do, is persuade no one. It frightens a whole bunch of people on the one hand, and it completely turns off a whole bunch of other people on the other. Because if your hysterical predictions don't come true within the time frame that you said that they will, then what does any reasonable person do in that situation when they're not experts, when they are lay people? Well, they tend to switch off from listening to you in the future, even if you are an expert, even if you're a scientist who is the best qualified person to actually explain what is likely to happen given this particular scientific theory of, for example, the climate. And so it's not that we need to accept that sometimes scientists get things wrong and everyone needs to be taught that. It's that the scientists themselves, when making a prediction, have to very carefully calibrate the language that they use surrounding that prediction. And if they say things like, for example, all the dams are going to run out of water by 2020, and we're all going to be in a serious situation where we can't even find drinking water. This was said in Australia, by the way, by some experts back in 2005 or 2010. And when that does not come to pass, and in fact we end up having floods, if the same experts turn around and say, well, it's not the drought that came due to climate change, but rather the floods, in other words, any set of weather events that occur can be attributed to climate change, it is quite understandable that people begin to switch off. Which brings me to academics today of all different stripes who make similar noises about the ways in which there's going to be demise on planet Earth. There's going to be regression on planet Earth. There's going to be technological demise. There's going to be increasing amounts of starvation if we don't do this or that other thing. And that was somewhat hinted at in the episode of Making Sense Today, released April 6, 2021, if you're interested in having a listen to that. The idea was that if we didn't go down the road of this particular solution, namely laboratory creation of particular kinds of meat, which I think there's nothing wrong with, by the way, but if we didn't choose to go down that road, then there would be massive amounts of starvation. This is the typical Malthusian argument, namely that because there's a finite amount of land, but the amount of people on the earth continues to grow, logically speaking, we can only support so many people given the amount of land. But this has always been shown to be false. We have vertical farms now, by the way. I talked about that in another episode. Vertical farming largely for the purpose of growing vegetables and plants. But there's no reason why you couldn't have a vertical farm of chickens and cows. Now, of course, I understand the animal rights people would be horrified if we had a skyscraper full of chickens and cows and sheep. But I'm just saying that this is the kind of thing where if only one solution is proposed to be the solution to any particular problem, it leads to this pessimistic idea and this kind of authoritarian totalitarianism where the person with the purported solution says, if you do not enact my solution, then things will go catastrophically wrong. It's an existential threat. But this is just a failure of imagination on the part of certain public intellectuals. There will always be human creativity which can find alternate solutions to particular things. And what does this have to do with today's episode? Well, the beginning. Even though we continue to have people who say, things look terrible for humanity, things are getting worse, if we don't solve this problem, we're going to go extinct. This has always been said. There are very few thinkers throughout recent history who, like David Deutsch, have promoted the idea that human creativity can and has been used and will continue to be used to solve the most pressing problems, and who've observed that it is Enlightenment ideas that have existed for the last few centuries that explain why things continue to get better. There's an explanation as to why. It's not merely a trend of getting better. Now, Steven Pinker writes about the trend and all the examples of how it is that things have gotten better. It's not that it's inevitable that it gets better, but there is an underlying explanation about, as the beginning of infinity lays out for us, a culture of criticism, of people thinking of new ideas and being able to think of new ideas because they're free to think of these new ideas. They've been trained in a certain extent, educated in a culture that says it's okay to criticize these ideas. Not to say that we couldn't do a lot better on that front, but we have begun to reveal how it is that we generate new ideas, how we're able to innovate. And we have people who in real life actually do this, who innovate and who identify people who innovate, like Naval Ravikant. Then isn't it all the more exciting and wonderful that we actually have a genuine concrete way in which the beginning of infinity can inform our worldview, personally, individually, in terms of the corporate world and in terms of governments and other kinds of institutions that can explore the space of possibilities in a positive, optimistic way without being concerned and sidetracked about all the ways in which people are either the cause of the problem, people themselves are an evil in some way, or that there is almost no hope and that what we have to do is to merely reduce the amount that we're producing, reduce the amount of energy that we're using, concentrate purely on efficiency gains wherever we can because we're running out of resources, which again was mentioned today. But we're not running out of resources. We talked about that during the previous chapter. Let's, after this extremely long introduction, get into the reading of the beginning, chapter 18, which is the final chapter of the beginning of infinity. Let's go. David begins with a quote from Isaac Asimov in his book, The End of Eternity, published in 1955, where Asimov wrote, "This is Earth, not the eternal and only home of mankind, but only a starting point of an infinite adventure. All you need do is make the decision to end your static society. It is yours to make. With that decision came the end, the final end of eternity, and the beginning of infinity." And then David goes on to write, "The first person to measure the circumference of the Earth was the astronomer Eratosthenes of Cyrene in the 3rd century BCE. His result was fairly close to the actual value, which is around 40,000 kilometres. For most of history, this was considered an enormous distance. But with the Enlightenment, that conception gradually changed. Nowadays, we think of the Earth as small. This was brought about mainly by two things. First, by the science of astronomy, which discovered titanic entities compared with which our planet is indeed unimaginably tiny. And second, by technologies that have made worldwide travel and communication commonplace. So the Earth has become smaller, both relative to the universe and relative to the scale of human action." Okay, just pausing there as a little side comment here. How did Eratosthenes figure out the circumference of the Earth in like 200 BC, something like that? So how he did it was he had heard, purportedly, he heard that there's this town called Cyrene, and in this town called Cyrene in Egypt, there was a well, and the well, one day during the year, this well, the sun above it cast no shadow. It just shone straight down into the well, and so you could see the very bottom of the well, which is interesting and rare. So rare, it only occurred one day of the year, purportedly. Now, he wasn't in Cyrene. He was in another town, city rather, called Alexandria. And in those days, the unit of measurement was the stadia, and so the distance between the place where the well was, casting no shadow, and Alexandria was about 5,000 stadia. And so what Eratosthenes' method involved, and school children do this now, was to, take a stick of some sort, put that in the ground, and then measure the length of the shadow that stick cast at noon on that same particular day. And the length of that shadow, trigonometry, gives you a particular angle. At the time, actually, the angle that he got was about 7.2 degrees, which is about 1/50th of an entire circle. So he knew that if he knew the distance from Alexandria to Cyrene, which he knew, and he got within, I think, a few percent of what the actual value of the circumference of the Earth was. Okay, back to the book. And David writes, "Thus, in regard to the geography of the universe, and to our place in it, the prevailing worldview has rid itself of some parochial misconceptions. We know that we have explored most of the whole surface of that formerly enormous sphere, but we also know that there are far more places left to explore in the universe and beneath the surface of the Earth's land and oceans than anyone imagined while we still had those misconceptions. In regard to theoretical knowledge, however, the prevailing worldview has not yet caught up with Enlightenment values. Thanks to the fallacy and bias of prophecy, a persistent assumption remains that our existing theories are at, or fairly close to, the limit of what is knowable, that we are nearly there, or perhaps halfway there. As the economist David Friedman has remarked, most people believe that an income of about twice their own should be sufficient to satisfy any reasonable person, and that no genuine benefit can be derived from amounts above that. As with wealth, so with scientific knowledge. It is hard to imagine what it would be like to know twice as much as we do, and so if we try to prophesy it, we find ourselves just picturing the next few decimal places of what we already know. Even Feynman made an uncharacteristic mistake in this regard when he wrote, quote from Feynman, "I think there will certainly not be novelty, say, for 1,000 years. This thing cannot keep going on so that we are always going to discover more and more new laws. If we do, it will become boring that there are so many levels, one underneath the other. We are very lucky to live in an age in which we are still making discoveries. It is like the discovery of America. You only discover it once." Feynman, The Character of Physical Law, 1965. Pause there, just my reflection quickly. No, it's not like the discovery of America at all. No, it's more akin, I suppose, to the discovery that there are other galaxies. Now, it used to be thought that the Milky Way galaxy was the entirety of the universe, and then it became clear that there were indeed other galaxies, islands of stars, just like our own, far beyond the Milky Way galaxy. And once we kind of realized that, it gradually became a realization to us that there were just many, many, many more galaxies, hundreds of billions, perhaps an infinite number of galaxies. And in the same way, our theoretical knowledge, our knowledge of science, our knowledge of philosophy has no bottom to it. There's no final foundation that we can get to. Every time we dig a little further and find something more and new and interesting, we can ask the question, why that? And why is it that way? And can it be improved in some way? And it can. But it is the rare person that thinks so or takes seriously that idea. Some people pay lip service to it and in some modes appear to be fallibilists or who believe in progress. But so many people, the overwhelming majority of people, certainly the overwhelming majority of public intellectuals, think that, as David just explained there, that we're almost there, that we're just about at the end of physics or the end of science, as David is going to come to quite a famous book called The End of Science by John Horgan, about all the ways in which progress must necessarily come to an end in some way. And these are the sentiments of, I would say, a majority of physicists. That we've got, for example, the standard model of particle physics. Okay, this is the explanation of all the different particles and the way in which they interact one with another. And it seems as though many think that we are just about there. We might have to find the graviton, okay, the particle that is the smallest particle of gravity. And then we'll just about have everything. And maybe we'll need a few other particles as well, but essentially we're almost there, we're almost done. Or perhaps it is that there's a layer beneath the standard model, maybe it's string theory, but once we figure out what all the modes of vibration of the particular strings are, then we'll be done. And, that will be the end of particle physics, that'll be the end of the fundamental physics. This is why we have Michio Kaku releasing a book just very recently called The God Equation. And the God Equation is something that even Paul Davies talks about in his books, which is the final equation, the final explanation, so to speak, of fundamental physics, about how all the forces actually interact. This is supposed to be the final theory of physics, where at the moment we've got a unification. The physicists have figured out how to unify magnetism and electricity. So we have this single force, electromagnetism now. And then some smart people figured out that, well, you can actually unify another force called the weak force. The weak force is the force that helps to explain what's going on during radioactive decay, for example, how you can have electrons coming out of the nucleus. Interesting process, among other things. And this weak force can actually be united with the electromagnetic force. And so we have the electroweak force, and some people won the Nobel Prize for figuring out the electroweak force. And so what we have to do now is to figure out, well, how do we unify the strong nuclear force, the force that keeps the nucleus together, with the electroweak force? And once we have this, we'll have the electroweak strong force or something like that. And this would be called a grand unified theory. But that grand unified theory would still be leaving out gravity. Now, we know from general relativity that gravity is not a force. However, these people who are kind of particle physics fundamentalists think that everything must be ultimately constituted of particles, and so there must be a particle that mediates the gravitational force, even though it's not a force. And when we have that, then we'll have a unification of the electroweak strong force with gravity, and that will be a so-called theory of everything. And David talks about that right at the beginning of The Fabric of Reality as well, that this wouldn't be a theory of everything because you could always ask, why does it have that form that it does? There would be layers beneath that. There would be no end to, trying to understand physics once we have this so-called theory of everything, if indeed it's possible to have a theory of everything. So far, all attempts via this route to continue to unify the forces, to unify these forces with gravity, have failed. But let's go back to the book. And David writes, among other things, Feynman forgot that the very concept of a law of nature is not cast in stone. As I mentioned in chapter 5, this concept was different before Newton and Galileo, and it may change again. The concept of levels of explanation dates from the 20th century, and it too will change if I am right, that as I guessed in chapter 5, there are fundamental laws that look emergent relative to microscopic physics. More generally, the most fundamental discoveries have always, and will always, not only consist of new explanations, but new modes of explanation. As for being boring, that is merely a prophecy, that criteria for judging problems will not evolve as fast as the problems themselves, but there is no argument for that, other than a failure of imagination. Even Feynman cannot get around the fact that the future is not yet imaginable. Just on this, pausing there, just my reflection on this, just on this distinction between fundamental and emergent, and it's my reading of David Deutsch's work that has made me think these two concepts are not really at odds. There can be emergent laws, in other words, laws that come from the outworkings of the laws of physics, or principles that come from the outworkings of the laws of physics. They emerge from, but they're still fundamental. In other words, fundamental, but that we consider, appear in many different fields, in the explanations of many different kinds of disparate phenomena. Now, take, for example, evolution by natural selection, that process, neo-Darwinism, if you like, this process of where the selfish gene survives and tends to get itself replicated. That is a fundamental law, but it's also emergent. It's both fundamental and emergent. These two things do not have to contradict one another. It is required in order to explain all of biology, one would dare say. And so it is fundamental within that domain, and it may be even more fundamental than that. We don't know. But the thing is, it certainly emerged. It emerged from, well, it came after the Big Bang. It came after, once we had complex chemistry. It emerged somehow out of that. We don't know exactly how the process arose, but the process did arise. It did emerge from fundamental physics, but itself is fundamental. For all we know, the laws of physics mandate that evolution by natural selection must obtain. Also, my favourite example of this is the existence of people and what a person is. A person is fundamentally important in the technical sense of fundamental, namely that they have effects upon every other domain that is conceivable. In principle, they have effects upon planets. They can have an effect on chemistry. They certainly have an effect on ecosystems and biology. They have an effect on how knowledge is created. In fact, they are unavoidably necessary in the explanation of how explanatory knowledge arises. You need to have a person there. And so I'm starting to think that people are really deeply fundamental to the cosmos. Maybe not human beings, but people. And maybe the laws of physics are such that no matter how, if you rewound the tape of the universe, that you consistently get people arising. I don't know. There doesn't appear to be evidence for that. But here's a philosophical argument that might be the case because at the moment, we human beings, being the only people that we know of, appear to have this effect on every other physical system that we're aware of to some extent. Every other physical system on the planet that we're aware of to some extent. Eventually, we're going to have effects on every physical system in the solar system, the galaxy, and so on. So people are fundamental in a deep sense. But at the same time, of course, we're emergent. We're very, very emergent. We're one of the most emergent structures that exists as well, but still fundamental. Okay. And just on the idea of new modes of explanation. So a mode of explanation would be something like, well, prior to evolution by natural selection, this idea that things can compete one with another, and one can be more fit in a particular environment and cause itself to be replicated more frequently than another, which might die out. This, the unit of selection in this case is a gene, but it wasn't always known to be a gene. It was thought to be maybe a particular individual in a species, so on and so forth. This is a new mode of explanation. No one had thought of that way of explaining things prior to evolution by natural selection. But eventually that mode of explanation is probably a precondition, is a precondition in some sense to Popper's own idea about how knowledge is created and knowledge tends to spread. It's not a perfect analogy, but there is it's within that same similar mode of explanation, but Popper, of course, applies it to the abstract ideas of knowledge, whereas Darwin, of course, was applying it to the very physical existence of species. Okay, back to the book. David writes, shedding that kind of parochialism is something that will have to be done again and again in the future. A level of knowledge, wealth, computer power, or physical scale that seems absurdly huge at any given instant will later be pathetically tiny. Yet we shall never reach anything like an unproblematic state. Like the guests at Infinity Hotel, we shall never be nearly there. There are two versions of nearly there. In the dismal version, knowledge is bounded by the laws of nature or supernatural decree, and progress has been a temporary phase. Though this is rank pessimism by my definition, it has gone under various names, including optimism, and has been integral to most worldviews in the past. Pause there, my reflection. Integral to, perhaps, most worldviews in the present, I would say as well. As David goes on to say, quote, he writes, in the cheerful version, all remaining ignorance will soon be eliminated or confined to insignificant areas. This is optimistic in form, but the closer one looks, the more pessimistic it becomes in substance. In politics, for instance, utopians promise that a finite number of already known changes can bring about a perfected human state. And that is a well-known recipe for dogmatism and tyranny. Pause there just to unpack that. So he says that utopians, in the political sense, promise that a finite number of already known changes can bring about a perfected human state. And that is a well-known recipe for dogmatism and tyranny. Yes, so any time you hear any of the ways in which to organize society that will provide a final answer to suffering and to human wants, okay, which is, let's just pick on communism. Communism purports to be the system where everyone will get their fair due, and that will be the end of it. It will bring about a kind of perfected human state, this Marxist idea. And so therefore you need to do what you can to implement this, and that leads to dogmatism and tyranny. Unlike the alternative view is just freedom, allowing people to pursue their own happiness and wealth. And we don't expect there to be perfection at any point. We expect just gradual incremental improvement. Far better than stasis, far better than this idea that we have the final utopian view, where everyone will have what they need to the extent they need it. And so, this utopian ideal is perfectly summarized by, Karl Marx. Karl Marx comes up with this quip, from each according to his ability to each according to his needs. And so the idea there that, the communist regime would solve the problem of how to fairly and equally distribute goods and services and capital and so on. And so everyone will have enough for their needs. But you will never have enough for your needs. You will always have more needs, and that's a great thing. You will always change your mind, your interests. You will always need more. And that's a really good thing. You'll always want to improve your computer, your car, the kind of food that you eat, the fashion you're interested in, the kind of entertainment you pursue. These needs should be unending in their change and the way in which they adapt according to people's new inventions. And so there can be no final solution to what people's needs are. And people with these kinds of political ideas think that, as David says, there's just a finite number of steps in order to get us there. We'll just change this, we'll change that, we'll change that, and then we'll instantiate this perfect society, this perfect way of organising people so that they have precisely what they need. But they can't be given precisely what they need, and there shouldn't be a finite number of changes, because we know that we need to change all the time. We need to be able to adapt and be fast in our adaptation, given that the problems that will come are always unpredictable, inevitable, and we don't know what direction they're coming from. So we need to allow them the agility to change whatever they're doing at any given point in time. Their needs will change at any given point in time as well. All right, back to the book. David writes, in physics, imagine that Lagrange had been right, that the system of the world can only be discovered once, or that Michelson had been right, that all physics still undiscovered in 1894 was about the 6th place of decimals. They were claiming to know that anyone who subsequently became curious about what underlay that system of the world would be inquiring futilely into the incomprehensible, and that anyone who ever wondered at an anomaly and suspected that some fundamental explanation contained a misconception would be mistaken. Michelson's future, our present, would have been lacking in explanatory knowledge to an extent that we can no longer easily imagine. A vast range of phenomena already known to him, such as gravity, the properties of the chemical elements, and the luminosity of the sun, remain to be explained. He was claiming that these phenomena would only ever appear as a list of facts or rules of thumb to be memorized, but never understood or fruitfully questioned. Every such frontier of fundamental knowledge that existed in 1894 would have been a barrier beyond which nothing would ever be amenable to explanation. There would be no such thing as the internal structure of atoms, no dynamics of space and time, no such subject as cosmology, no explanation for the equations governing gravitation or electromagnetism, no connections between physics and the theory of computation. The deepest structure in the world would be an inexplicable anthropocentric boundary, coinciding with the boundary of what the physicists of 1894 thought they understood. And nothing inside that boundary, like, say, the existence of a force of gravity, would ever turn out to be profoundly false. Pause there, just my reflection. And so it's true today. Again, we can look back now and kind of giggle at how silly Michelson must have been. After all, as we learn in the book, and as any student of physics can tell you, Michelson was one of the people who helped to popularise the idea of relativity by Albert Einstein, the Michelson-Morley experiment, which was an attempt to detect the luminiferous ether, the movement of the Earth through this luminiferous ether, which was required for prior theories about light prior to, Einstein's special relativity. Prior to this, they thought, well, light's a wave and it needs a particular medium to move through that material is the luminiferous ether. So Michelson himself was instrumental in many ways, experimentally helping to refute other theories in favour of Einstein's own theory of special relativity. And so he himself, even though he thought physics was all tied up into a nice neat bundle, was one of the people who showed that in fact it wasn't. And I think, David will come to this in the chapter as well, that now more than any other time it seems quite obvious that we don't know everything. There are just so many problems that seem to point to deep issues with our most fundamental theories across the board. It's not to say that they're wrong in all parts, in the same way that Newton's theory of universal gravitation wasn't wrong in all its parts, but it contained misconceptions. And so we must think now that our greatest theories themselves contain misconceptions. As David also says, wouldn't it be wonderful if we just agreed to call our scientific theories scientific misconceptions, that our best misconception at the moment is about gravity is the general theory of relativity. Others have been falsified, but this misconception has not yet. But right now we have serious problems. I mean, why do galaxies rotate at the rate that they do? We don't know. We postulate this thing called dark matter. And the best explanation seems to be, well, it has to be a kind of matter. It must be, because we know of no other thing, no other entity that can create gravitation. But purely speculating, it could be the case that some of these very clever scientists, physicists who are saying, well, maybe, just maybe, general theory of relativity is the problem. And if we solved whatever the problem was with general relativity, coming up with a new theory of gravitation, we would solve these galaxy rotation curves, among other things, among other reasons for thinking that dark matter exists, or this phenomena that seems to be causing these anomalous observations, which we call dark matter, could be solved by another theory of gravity. So we have this problem of dark matter. That's one thing. Another issue is, of course, and we will come to this, I won't say too much about it, dark energy. Why is the universe expanding at an accelerating rate? We don't know. This could be a very serious problem for the foundations, for the fundamentals of physics. Why does quantum theory say that things are discrete and general relativity says that things are continuous? What is the fundamental, deepest nature of reality in truth? Is it discrete or continuous? Is it a third thing that doesn't fit into either of those categories? That could be interesting. I doubt it. And many people, physicists, have been trying things like string theory, seemingly without success in physics so far. We have Lee Smolin, who talks about loop quantum gravity, and maybe that's an avenue that might reveal something about the deep nature of gravity and how it can be combined with quantum theory. Maybe David Deutsch and Chiara Maletto, who work on constructor theory, among other people. Maybe they have an avenue towards a quantum theory of gravity or a new way of unifying these things. There are mysteries aplenty within physics. And so we could talk about all the things that we don't know in physics right now. What is the nature of consciousness? What is the geometry of the multiverse? What effect would a quantum theory of gravity have for the quantum theory of computation? Would there be any effect at all? I don't know. Why do the constants of nature have the value that they do? This is one thing that I'm very curious about. I know some people are working on this, the so-called fine-tuning problem. I don't think there is a satisfactory answer for these things. Maybe there is a megaverse out there. Again, another open question in cosmology and physics. Let's go back to the book. Nothing very important would ever be discovered in the laboratory that Michelson was opening. Each generation of students who studied there, instead of striving to understand the world more deeply than their teachers, could aspire to nothing better than to emulate them, or at best, to discover the seventh decimal place of some constant whose sixth was already known. But how? The most sensitive scientific instruments today depend on fundamental discoveries made after 1894. Their system of the world would forever remain a tiny, frozen island of explanation in an ocean of incomprehensibility. Michelson's fundamental laws and facts of physical science, instead of being the beginning of an infinity of further understanding as they were in reality, would have been the last gasp of reason in the field. I doubt that either Lagrange or Michelson thought of himself as pessimistic, yet their prophecies entailed the dismal decree that no matter what you do, you will understand no further. It so happens that both of them had made discoveries which could have led them to the very progress whose possibility they denied. They should have been seeking that progress. Should they not? But almost no one is creative in fields in which they are pessimistic. Pause there, my reflection. Well, let's just take that seriously. Almost no one is creative in fields in which they are pessimistic. You can take that as a personal injunction to be optimistic. If you want to be successful, don't be pessimistic. Don't think that you can't make a difference. Don't think that you can't contribute. You can, and you should try. And it's only by accepting that as a precondition to making progress, thinking that you can make progress, thinking that you can be creative, that you will. Okay, this idea that progress must stop at a particular point is a good barrier to you making progress. Okay, let's keep going. David writes, I remarked at the end of chapter 13 that the desirable future is one where we progress from misconception to ever better, less mistaken misconception. I have often thought that the nature of science would be better understood if we called theories misconceptions from the outset, instead of only after we have discovered their successes. Thus we could say that Einstein's misconception of gravity was an improvement on Newton's misconception, which was an improvement on Kepler's. The neo-Darwinian misconception of evolution is an improvement on Darwin's misconception and his on Lamarck's. If people thought like that, perhaps no one would need to be reminded that science claims neither infallibility nor finality. Perhaps a more practical way of stressing the same truth would be to frame the growth of knowledge, or knowledge, not only scientific, as a continual transition from problems to better problems, rather than from problems to solutions, or from theories to better theories. This is the positive conception of problems that I stressed in Chapter 1. Thanks to Einstein's discoveries, our current problems in physics embody more knowledge than Einstein's own problems did. His problems were rooted in the discoveries of Newton and Euclid, while most problems that preoccupy physicists today are rooted in and would be inaccessible mysteries without the discoveries of 20th century physics. The same is true in mathematics. Although mathematical theorems are readily proved false once they have been around for a while, what does happen is that mathematicians' understanding of what is fundamental improves. Abstractions that were originally studied in their own right are understood as aspects of more general abstractions, or related in unforeseen ways to other abstractions. And so progress in mathematics also goes from problems to better problems, as does progress in other fields. Just pausing there, just my reflection. A Mathematician's Apology, that great book written by G.H. Hardy about his meeting with Ramanujan, the other great mathematician. I remember in that book, he quite proudly, and I think he would refer to the impractical nature of the pure mathematics that he did. So even the meta-mathematical point, the mathematicians who create mathematics thinking it definitely has no practical application are sometimes surprised there is a deeper understanding that in fact the mathematics does indeed connect to physical reality. Now, this is different, of course, to the idea that there can be mistakes made in mathematics. And just because, of course, a theorem is rarely proved false in mathematics, once it's been proved, it's rarely shown to, in fact, be an error. That doesn't mean that it can't be. Okay, as David is at pains to say, and that's a subtle point, that from the Fabric of Reality, and I love to quote this part of the Fabric of Reality, where he says that necessary truth is the subject matter of mathematics. Necessary truth is not the reward we get for doing mathematics, which is the difference between necessary truth is the subject matter. It's the thing that we're looking at in mathematics. But our knowledge of that, which is what mathematicians are engaged in, they're engaged in conjecturing ideas, they're engaged in creating knowledge about this domain, which we call the domain of necessary truth. And so they're coming to try and understand what necessary truths are. Now, when they produce a theorem, Pythagoras' theorem, they say c squared equals a squared plus b squared, I say this is a theorem. Well, we can have new understandings of that. Namely, when Pythagoras proved this, or when whoever did first come up with this, maybe it was Pythagoras, maybe it wasn't. This c squared equals a squared plus b squared seems to be a thing that applies not only in the physical world, but it's just incontrovertible. There's no way in which we could ever get around this. But of course, it's a special case that works in 3 dimensions. Now, I think back in the Greek times, I don't know if they thought of 4, 5, 6, n different spatial dimensions. And so you could have a variant of Pythagoras' theorem that operates in different dimensions. Not to say that Pythagoras' theorem is wrong, but it would be wrong to think that it applies universally in all possible mathematical areas. Okay, let's just go back to the book, and I'll read just a little more for today. We're going to spread this final chapter out, I think, to a few different parts. David writes, Optimism and reason are incompatible with the conceit that our knowledge is nearly there, in any sense, or that its foundations are. Yet comprehensive optimism has always been rare, and the lure of the prophetic fallacy strong. But there have always been exceptions. Socrates famously claimed to be deeply ignorant, and Popper wrote, I believe that it would be worth trying to learn something about the world, even if, in trying to do so, we should merely learn that we do not know much. It might be well for us all to remember that, while differing widely in the various little bits we know, in our infinite ignorance, we are all equal. End quote. That was from Conjectures and Refutations, published in 1963 by Karl Popper, just emphasizing again, in our infinite ignorance, we are all equal. There is an infinite amount that all of us do not know and are utterly ignorant of, and we're all the same in that. We just happen to have little bits of specialized knowledge. Einstein had specialized knowledge of physics. Popper had specialized knowledge of epistemology. Lavoisier had specialized knowledge of chemistry. We can keep on going. People sitting at home might have specialized knowledge of soccer or football or netball or art. Our own families, we have specialized knowledge, and we just differ in those little bits of specialized knowledge that we have, but we're all infinitely ignorant. There's an infinite amount that we don't know, and that will always be the case. Just the last paragraph that David writes there. He says, quote, "Infinite ignorance is a necessary condition for there to be infinite potential for knowledge. Rejecting the idea that we are nearly there is a necessary condition for the avoidance of dogmatism, stagnation, and tyranny." End quote. End the reading there for today, because David's about to launch into a description of his frenemy, John Horgan, The End of Science, which is basically the counterpoint to The Beginning of Infinity. And in fact, John Horgan did an interview with David Deutsch. And they got on very well, and they spoke all about The Beginning of Infinity. And I don't think John Horgan has ever changed his mind. He's been on Clubhouse recently, and he's talked about things like, well, he's in this book, amongst other articles, he seems to get Popper quite wrong. He seems to get the physics quite wrong. So he seems to make a lot of errors, which of course leads him to conclude that science is just about ready to be finished, because he thinks that, I suppose, that our scientific theories aren't grand misconceptions, and that we're replacing one misconception with the other. And when we read that earlier on, let me just go back and read what David says. David says that the desirable future is the one where we progress from misconception to ever better, less mistaken misconception. And so he's talking there about how we're correcting errors, and we're refuting what we hitherto regarded as our best theory. We change our minds in light of new evidence, and we find a new theory. But that theory, we must expect, also contains misconceptions. Now, does this mean that just everything is on equal footing as being misconceptions? No, because we're finding some amount of truth. Now, we can't quantify, we can't measure or weigh this amount of truth. All we can say is we've corrected errors. We've removed some misconceptions. We've removed some of the mistakes, some of the errors, and so we then have something else. Itself not perfect, and it will never be perfect. It's just that we're refining things, we're improving things, we're making progress away from utter and complete falsehood towards the ontological truth, towards a description of reality which is more accurate. Now, we can't quantify this. All we can say is, this theory is better than that theory, and that theory was better than that theory, and this theory C is better than B, which it succeeded, and better than A, which is the first one that we came up with, our first best guess. And B was better, and now we're at C. And we expect there to be a D, E, F, and we're going to get to Z, and then we'll have to start all over again with AA and AB and AC, and so on. You get what I'm saying. There is no end to this process of error correction and moving from misconception to better misconception, a less mistaken misconception. The wonderfully positive vision, which means that we'll never get to the end of science, and instead we are at the beginning of infinity. And we're moving towards the end of the beginning of infinity, but not yet. We have, I would say, at least 2 more episodes left here. And in the meantime, if you're waiting for more and you just can't wait to hear more about the beginning of infinity, go to David Deutsch's website, daviddeutsch.org.uk. And from daviddeutsch.org.uk, you can find links to, for example, constructor theory, and the constructor theory material at constructortheory.org has a lot of talks and interesting papers with David talking with the various other people talking about that beginning of infinity. Okay, that may very well be a beginning of infinity, the constructor theory of information, and this new approach to the fundamental laws of physics. And if you want still more, go to Naval, and if you just put into your browser nav.al, and that will take you to his website where his podcast is, and as myself and Naval having conversations there. Very short conversations that will continue for the indefinite future. So yes, you can go there and you can hear the conversation going on there. As I say, if you type in Naval Ravikant into YouTube, you will also find some conversations, some more lengthy conversations I've done with him on Clubhouse recently about these same issues. But until next time, bye-bye.